Okay, hello everyone. I'm John, and this is my colleague Ben. We work at Yelp, and we're both in the Engineering Effectiveness Group. And we're going to be talking to you about how we've started using Envoy at Yelp. So I want you to imagine that you've just got up in the morning. You're staring at yourself in the mirror, bleary-eyed, as you brush your teeth. Maybe you went to bed a little too late last night. You watched one episode too many of the Great British Bake Off. What are you thinking about? You might be thinking, what is the purpose of my existence? And this is a very interesting question, so please do think it. But I'm going to suggest that as an infrastructure engineer, perhaps there's a more important question that I might be asking. And that is, how can I make developers happier? And I think this is basically what my job boils down to, keeping other developers at Yelp happy. And so this story is about keeping developers happy in the context of Envoy. So let's talk about developer happiness. What do developers care about? I think they want to quickly ship bug-free code. And if they're doing that, this hopefully means that they can solve customers' problems. On the other hand, what are developers not so interested about? Well, often they really don't care about setting timeout values. People come to me, they say, John, should I be using 200 milliseconds or 400 milliseconds? I just don't know. And I'm like, I don't really know either. Like, I wish you could just ship your code, but yeah, let's figure this one out. It slows them down. They also, unfortunately, do not tend to care about new RPC technologies. I find the differences between Proto 2 and Proto 3 very interesting, as I'm sure many of you do too. Unfortunately, not everybody shares that enthusiasm. They just want to ship code. Okay. So, with that in mind, let's look at our first service mesh architecture at Yelp. So, we were using this up until about 2014. I call this, let's just manually configure HA proxy. And at that time, most code lived in our Python monolith on the left. And we also had a handful of services on the right. Search service and geocoder service shown here. And our monolith communicated with these services using a single redundantly provisioned HA proxy instance per data center. So let's return back to that developer happiness question. What's working well here? Well, developers can write services. That's a big deal, which means they can quickly ship their bug-free code. What's not working so well? Okay, so this is an email from an infrastructure engineer saying that they've just manually changed, yes, the HA proxy config to add some new servers, and they're going to reload that HA proxy instance, which is going to cause some user visible errors, sorry. So why is this going to make developers unhappy? Well, firstly, developers are unhappy anytime they're waiting on another person to do something for them because this slows them down. That's a pretty universal truth. And secondly, developers are unhappy anytime they have to acknowledge alerts because, they were writing code, trying to solve customers' problems, and now there's an alert going off, so they need to context switch. And so this kind of makes them happy. Let's look at another source of unhappiness. So this is a ticket that's documenting an issue whereby we're hitting capacity limitations on our single HA proxy instance. And this is causing 20 plus seconds of latency in one of our data centers. So we're like, well, quickly, get onto our other data center. And why does this make developers unhappy? Well, again, they were writing code, trying to solve customers' problems, and then suddenly every single service is alerting, and so they're all drawn away from what they were doing, and they have to focus on these issues. Okay, so it was pretty clear to us that our manually configured centralized service mesh was making developers a little unhappy. And I'd heard about Finagle, in particular the Zookeeper-based service discovery and client-side routing, and I thought this could solve these problems for us. The problem being with this, that Finagle only works on a JVM, and we're running lots of Python services. So what I did is I prototyped an in-process Python version of Finagle and shipped it to production, and the website fell over. because Python does not work very well with threading. Okay, there must be a better way of doing this. So we started thinking about building a sidecar process to perform service registration. And then in October 2013, Airbnb announced SmartStack, which does this for us. So we evaluated it, and we found that it did promise a big improvement over our first service mesh. So we started using it, and we've been successfully using it for the past 4 years. So for those of you who haven't seen it before, I'm just going to give a quick overview of the SmartStack architecture, and then Ben is going to talk about how we changed it shortly. So let's talk about the control plane first. So at the top right, you've got this nerve process that's health checking a couple of service instances. And if they're healthy, it registers those in Zookeeper. And top left on another host, you've got this Synapse instance. And all it's doing is getting these push-based notifications from Zookeeper and configuring a local HA proxy instance. And then over on the data plane, you've got clients, and their interface to the network is just HA proxy. That's all they're talking to. And HA proxy is routing to whatever service instances it's been configured with. And this is the basic design, and it works really well. I'm going to say it again, it works really well. So in particular, it allows us to reliably get bits across the wire. No more waiting on humans to configure those load balancers. No more alert floods every time a load balancer config changes, once you've figured out how to do zero downtime HA proxy restarts, which is another story. And no more scaling problems to a first approximation. So let's get back to that. What makes developers sad? Well, we've kind of solved most of the problems there. So we had to think a little harder. Maybe our job was done. Maybe not. So about a year ago, we started talking to developers. We asked them what was slowing them down. And we came up with a list. And I'm going to show you our particular list. Maybe your list is different. So here are a bunch of things that we got from discussions with our developers, along with some scores. If you went through the same exercise, you'd probably come up with a different list with different scores. And let's just focus on the things on the left, the descriptions. So developers said that they'd really quite like some standardized circuit breaking, retrying, and timeouts. They were tired of having to figure out those values themselves. They wanted us infrastructure engineers to take care of those problems for them. Okay. They also wanted some dynamic request routing features so that they could, for example, deploy services into production and just test them out themselves before exposing them to everyone else. They also talked about some rate limiting, fault injection, and permissioning. So now let's zoom in on one of these, dynamic request routing. And we've given it a score of 70. So I'm just going to tell you how we reached that score. So basically, it's a weighted sum of factors, some positive and some negative. And there's nothing special about these factors, but we felt that they were important for our organization. And we also wanted to be a little principled about this exercise. So let's start with the positive factors. What's good about dynamic request routing? Well, developer happiness, we score 3 out of 3. We think there's a big win for developers from this. And there are also high benefits from developer velocity and also a little bit positive on stability and operational costs. But as all of us know, whenever we make a change, there's also some downsides, so we tried to capture those as well. So, what are the negative effects to the business? Well, we thought it was pretty risky if we were to implement this thing. Potentially, we could bring the website down. And we also thought it was difficult. So that was how we arrived with our score. So we identified a bunch of problems, and then we went looking for ways that we could solve them. And we realized that a lot of these problems could be addressed by building a smarter service mesh. So we evaluated the available options here. We firstly considered extending HA proxy. We'd already written some custom Lua script plugins to do fault injection. We thought we kind of knew it pretty well. Maybe we could even start hacking on the C code. We seriously considered this. Another option is we'd heard of this upstart called Envoy, and we thought it looked pretty interesting. Maybe that was worth a look. And there was also Linkerd. We also pretty seriously considered that. And cutting a long story short, we picked Envoy, which is why we're here. And with that, I'm going to hand you over to Ben, who's going to talk to you about our move to Envoy.
Thanks, John. So at this point, we knew that we wanted to go to Envoy. There were a lot of features that our developers were going to benefit greatly from, but we knew that there was a lot of risk. So John showed you this slide earlier. We know that there are some things that developers like and developers don't like, but we actually missed one here. And that is that developers hate getting woken up in the middle of the night because their service mesh broke. So infrastructure development is inherently risky. There's no getting around that, not with any cloud-native technologies. It's just risky. Most developers, I would venture to say, would probably rather have you not change anything than to break it by upgrading to the newest shiny thing. But we also know that Envoy is going to make their lives better. So how do we rectify these two? And we took a page from the software development world and tried to apply the agile techniques. So I'm going to talk for a little bit about how we rolled out Envoy using agile techniques. And I'm going to specifically talk about incremental development, the idea of cut points, and CI and CD. So let's first talk about incremental development. So John showed you this SmartStack architecture before. And honestly, oftentimes the temptation is to just rip this whole thing out and replace it with the thing that everybody else is using. So maybe that's Kubernetes with Istio or whatever. But that's really disruptive, and that makes developers unhappy, and we don't want to do that. So the new architecture that we came up with, which was an incremental improvement over this, is this. So I'm just going to flip back and forth, see if you can spot the difference. There, old and new, old, new. And yeah, it's just this. We basically replaced one part of the control plane, and we replaced the proxy with Envoy. So our long-term goal is to go to this ideal infrastructure, Kubernetes, Istio, whatever. But we need to make incremental improvements. So I'm going to take a quick detour to talk about our control plane. I don't want to go into too much detail because I feel like it's very similar to other control planes. But why did we write our own? We could have used an existing one. We could have used Java control plane or Go control plane, but we didn't. We're more comfortable in Python, and we like flat files. So this is it. It's pretty much pulls, this meshed thing is less than 1,000 lines of code. It pulls service registration data from Zookeeper, pulls some manifesty type stuff from flat files, writes out some flat files in XDS format, and Envoy reads it. It's really, really simple. And we do plan on, going to some gRPC system or whatever, but this is the simplest incremental improvement that we could have made. And at this point, we had some sort of control plane. We could have tried to get to feature parity with our existing system. We actually have a ton of features in our existing system. We built in like fault injection and chaos testing and all that stuff in our existing system. We could have gone to feature parity, but that's really risky. So the idea of a tracer bullet comes into play here. And a tracer bullet is getting a narrow use case solved end to end. So you might be familiar with this page. This is kind of like a business page on Yelp. And if we were to try to migrate all of this traffic, this is pretty complex. There's a lot of things going on here. And if we were try to get all of this through Envoy, it would have taken a very long time and would have been very risky. So what we did instead was we just picked one little part, this little Ask the Community part, and within a quarter, using incremental development, we were able to get this up and running routing through Envoy. So we did a very simple thing, end-to-end, very quickly. And as a bonus, if this fails, we have some users and some developers that are mad at us, but it's not likely to take down the whole site. So some key takeaways about incremental development: make small changes rather than large overhauls. You shouldn't ever break anything. Well, that's a pretty broad statement, but each version should be usable. And yeah, don't try to solve every use case immediately. If you can, use tracer bullets. And so the next thing I want to talk about is the idea of this cut points. But first, I'm going to take a quick digression to client libraries, and you'll see why in a second. So to talk to a service at Yelp, you can just use curl. Our developers like that. But you can also use a client library, and this is generally what people use. So a client library is generated from an API spec. We have client libraries in different languages. I'm sure this is a familiar concept. Here's the actual code example. If you want to talk to an example happy hour service, you instantiate it, and you make an RPC call just like that. We've done a huge amount of work to get people on client libraries. And we have a similar one for databases. We have this in a few different languages. But I know what you're thinking. Isn't Envoy supposed to replace client libraries, or maybe replace a lot of it? So it's all about balance. Thick client libraries have a lot of problems. Sorry, finagle. You need to maintain multiple implementations. As these client libraries start to live longer, they start to get more features, and you have to maintain that over multiple languages, and that's a lot of work. Upgrading everyone is a nightmare. We have hundreds of services, and upgrades for our client libraries take a very long time. I'm sure many of you have experienced this. This was actually a huge driver for us to move to Envoy. We wanted to make our client libraries simple, so that we could control a lot of that. However, you still need some sort of thin client libraries, and there's some useful things that you can do there. Context propagation, for example. Say if you want to do Zipkin tracing, injecting that context onto the wire is really useful to do in the client library. And setting X Envoy headers, for example, is something that you can abstract away in the client library. Things like data marshalling as well. And if people don't use them directly, at least they can serve as a reference implementation. And the last thing is that client libs are a great cut point. So a cut point is, I don't know if it's a common term, but it's a term that we use, meaning that it's a place where you can do a little bit amount of work and have a huge amount of impact. So since we had already done the work to migrate people to client libraries, this is a great place where we can do some migrations. So it's literally this. This is a simplified example, but it's not very many more lines of code in reality, which is that we change the client library to have a little feature toggle there that says, basically, if the feature toggle is enabled, route through Envoy, otherwise route through HA proxy. And this is great for a number of reasons. Firstly, the developers don't even know that they're routing through Envoy. They have no idea that we've switched them over to use Envoy or HA proxy. I mean, we do tell them. We're not that evil. But it also enables us to do phased deployment, which we'll talk about in a little bit. And finally, it allows us in bad scenarios to shut off Envoy routing for everybody as a kill switch. One other place cut points are useful is for things that developers indirectly use, such as observability tools. So this is our existing log processing pipeline. We have HA proxy that logs to some log processor, and this thing spews out a bunch of structured logs. For example, we extract Zipkin tracing from here, we do some alerting, we send logs to Splunk. It's pretty complex and pretty well used by developers. So the first option would be to rewrite this. But the risk of getting this wrong is really high. If we lose some of these things, then developers are really unhappy, and it's a lot of work. Another option would be to extend this to accept Envoy's gRPC-based access logs. But this can be risky as well, mainly because the existing code is large and kind of unwieldy. So the option that we went with is to actually have this separate thing that munges the Envoy logs and makes them look like HA proxy. So the log processor thinks that it's consuming HA proxy logs, but in reality, they're coming from Envoy. And this allows us to support the old system and gradually move away from it. And the developers don't even know the difference. They see the logs, they see the Zipkin traces, they see the logs in Splunk, and they're happy. This is kind of like a branch by abstraction, or maybe branch by abstraction in reverse. So yeah, takeaways for cut points. Find places where you can do have a lot of impact for a little bit of amount of work. And use shims for an abstraction layer, and also feature toggles are amazing. So lastly, I'm going to talk about continuous integration and continuous deployment. So I don't know about you, but this is kind of how I knew infrastructure development. You want to make a change, you make an upgrade, you find a host that maybe there's some people on it or maybe not. You run some upgrades on it, you run some manual tests, maybe you break things, and then you deploy it to prod and you pray. And sometimes you're lucky and you claim that you're really smart, and other times you get unlucky and you say that the gods have smitten you. But I'm going to claim that infrastructure is not an exception to good software development practices. We have automated tests. We're used to this. So why not write automated tests for our system? This is real code from our control plane tests. We run end-to-end tests using Docker Compose. And I'd venture to say that I'd be willing to bet that if Zookeeper went down right now in our environment, then we'd still be able to route through Envoy because we've tested it. In this example, we bring up a bunch of services at Zookeeper and Envoy, and then we start killing them and making sure that we can still route through it. So this gives us a lot of confidence when we deploy. And as a bonus, you can use these end-to-end tests in your GitHub issues on Envoy. So when you're struggling to explain what exactly is happening, rather than trying to explain it in words, just point to some Docker Compose scripty thing and say, hey, just run this. This is exactly what I did here. But no testing discussion would be complete without the test pyramid. Make sure you still have integration and unit tests. End-to-end tests are still slow, so you can't get around that. Sorry. OK, yeah, takeaways. Write automated tests. Docker Compose is amazing for running end-to-end tests. Run against master if you can stomach it. We, during heavy development, will deploy master of Envoy up to once per week. It's great quality. I'm pretty confident in it. And the last point is about phased deployment. So phased deployment is the idea that you want to roll out to kind of safer environments first and then do a gradual rollout. And this is really important, and I'll tell you a story why. So one day, I shipped a change to add distributed health checking to Envoy. And within a few minutes, alerts started firing. And it turns out that a combination of a misconfiguration in our control plane and an Envoy bug caused Envoy to DDoS our services. We did have tests for this, and we actually did roll it out to a staging environment first. But because distributed health checking is O of n squared, it only failed when we scaled it up to a larger phase. So this is not the only time it happened. We had John also DDoSed our environment. I'm not the only one that did this. But because we were able to deploy in phases, the damage was minimal, and we were able to roll back quickly. And remember that Envoy is part of pretty much everything when you roll it out. So if you break something, bad things will happen. Developers will get unhappy. So just to recap, yeah, apply incremental development everywhere. Identify cut points where you can kind of do a little bit of work and have a lot of impact, and use CI/CD. So yeah, in summary, this is amazing. This is awesome that we get to work on this. No, OK. Focus on your users. That's why we're here. We're not here to play with cool toys, though it's fun. Yeah, thanks. And here's the obligatory we're hiring slide that I have to put in here. Any questions? OK. I know everybody's hungry. Yeah. Yeah, the question was about this this kind of branch by abstraction thing with the access logs. And yeah, the long-term goal is to actually move over to using this new system. So we have to support these two systems in parallel. But yeah, eventually we won't be using HA proxy at all, and we'll have only this new access log munger or whatever. We'll actually do more things. We were originally going to call it Envoy to HA proxy, but that will become a useless name very quickly, so we just called it Bike Shed. Any other questions? I know everybody's really hungry. Me too. All right, thanks.